All right, so in this video, I'm going to go over the analysis of our IR spectra, the type of analysis that I would expect to see in your lab notebook for every lab where we actually take an IR. Okay, so this would be your spectra that you have pasted in your notebook. This is my example spectrum here. The very first thing I'm going to do is I'm going to cut it up into its respective regions, right? So I'd like to use nice whole round numbers. So 1500, 2000, and 2500. These are these different regions in our IR spectrum. Hold on, let me straighten out this line. Okay. I'll just label these here so we can be good. On the very right-hand side here, we got the fingerprint region. And what do we do with the fingerprint region? We completely ignore it. There is certainly some information here. If you're sort of more advanced at IR, as far as I'm concerned, I don't look down there. I don't know what's going on down there. Don't really care. All right, the next region up is where our double bonds will live. Next region are where triple bonds live. And then finally, we have our anything bound to hydrogen region. And this is the biggest region of our spectrum, and usually where our most interesting functional groups live, or at least a lot of them. There's one way that you can help sort of analyze this portion of the spectrum, and that is to lay down yet another line at 3000. This will distinguish between this group of peaks that we see quite often, this one right here, which are our sp3 carbon hydrogen peaks. But if we had a double bond or a triple bond, they would appear right over here for a double bond or over here for a triple bond. So that just kind of helps you see whether or not you have any sp2 or sp hybridized carbon hydrogen bonds going on. Okay, cool. So for each peak outside of the fingerprint region, or we can group this peak together here, this cluster of peaks, we always need to have the same information in our notebook. All right, so the first thing that we need is our wave number range. And you can approximate this based on the tick marks on your IR spectrum. Okay, you can use a ruler to help you get pretty good. Anything within 50 inverse centimeters is perfectly fine. All right. The next thing you need to do is characterize the intensity or the height of a peak. Whoops, can't spell. Intensity. All right, so this can be anything from weak to medium and all the way to a strong peak, a nice big peak on your spectrum. The next thing is the broadness of that peak. Is it narrow? Is it somewhere in the middle? Or is it a nice broad, or even maybe very broad peak for thinking about like a carboxylic acid? All right, and then lastly, you're going to need the bond that corresponds to that function, or that corresponds to that peak, right? Each one of these peaks is a result of bonds within our molecule vibrating at a particular frequency. So that's how we're able to see them. That's how we're able to determine functional group. So we need these 4 pieces of information for every peak that is above our fingerprint region. Okay, this is what I want to see in your lab notebook. If you want to do it directly on the graph, that's perfectly fine since these are taped into your lab notebook. But this is what I need to see. And then at the end, when you're all done, you're also going to give your proposed functional group. All right, so a functional group that would correspond to this spectrum. That's at the end of the day what we can determine from our IR. All right, so Let me show you what I'm going to do here for this spectrum. The first set of peaks I'm going to focus on are this right here. And these are actually the biggest hint as to what my functional group is in my molecule here. These peaks are, so let's see, where are we at? 450-ish? 3,450 rather. We'll just start it out at 3,400. Okay, so 3250 to 34. So that's my wave number range. Inverse centimeters, right? So that's step one. I got my wave number range. Check, check. The intensity, these are quite weak peaks. Not very big on my spectrum. Going, starting here at about my baseline around 100, and we only get to 97 maybe. So there's weak. They are still pretty broad. They're not the sharpest, hairline prints here. So I'm going to say they're medium broad. All right, and then this set of peaks, especially when there's two of them, corresponds to a primary amine. So nitrogen with two hydrogens on there. All right. This set of peaks here we see in a lot of our organic compounds, although I will say in the second semester we deal with a lot of benzene derivatives, which don't have any sp3 carbons in them. So we still want to make sure to analyze this set of peaks here. All right. Sure, we'll call it 2,800 to 3,000. These are nice and sharp. They're also quite narrow. There's a bunch of them stacked on top of each other, but they're quite narrow. And these correspond to sp3 hybridized carbon hydrogens. Okay, I have nothing in my triple bond region. If I go to my double bond region, I have this, and I will tell you that this compound, actually, we're going to figure it out on our own throughout our analysis here. So stay tuned. We'll figure out what this is after we look at the mass spec and the NMR, but I will tell you that this compound doesn't actually have any double bonds in it. Nonetheless, this is a peak outside of the fingerprint region, so I'm going to go ahead and analyze this here. Pretty much starts off exactly at 15, maybe a little bit higher, but what's this here? Probably 1650. Yeah, we'll call that 1550 to 1650. All right, this is, I don't know, in the grand scheme of things, we'll call it medium intensity. And it's kind of medium breadth as well, medium broadness. All right. This isn't one that I would expect you to know, so it's kind of surprising here because it's in this double bond region. This is actually a nitrogen-hydrogen bending peak. Most of our spectra, most of our peaks on our IR spectra are for bonds moving back and forth, for sort of vibrating back and forth, what they call stretching frequencies. Some bending frequencies are also visible. It turns out that there's a bending frequency for this NH bond, and that shows up in our double bond region. To be honest, that's a fun fact, but I wouldn't really expect you to know that. So if instead you just gave me an analyzed peak and said, I don't really know because I don't have a double bond in my compound, I'm okay with that. All right, but just fun fact, it is indeed a known nitrogen-hydrogen bending peak here. All right, but this is what we have to have for our spectrum. My proposed functional group then, you can say R dash would be a primary amine. I got my two peaks here, which is the signature of a primary amine. I only have sp3 hybridized carbons and hydrogens. So that's what I can do is say, this is sort of all that what I can get to here, is saying that, okay, I know that my compound is a primary amine. All right, but this is what you need to have for your analyzed IR spectra for every lab, for every spectrum that we take. You need to have these 4 pieces of information for each peak. Whoops, that's not how you number. And at the end, you need to have your proposed functional group. In this case, we could narrow it down. Maybe I don't have enough information to distinguish an aldehyde or a ketone or an ester, and so all of those are proposed functional groups. I'm just not sure yet, but I have to have a proposed functional group at the end.